Hello everyone, welcome to our channel. Today we are going to learn a very important basic concept in natural language processing called tokenization using the Python library NLTK. NLTK is nothing but natural language toolkit. If you're starting with NLP or machine learning, this concept is a must to understand. Okay, so NLTK, we are going to learn the basic steps of NLTK in this video. Um, Tokenization is the first and foremost step in almost every NLP task, such as machine translation, chatbots, sentiment analysis, and speech recognition also. Without tokenization, a machine cannot properly understand text. So we need to take care of that only. We are going for tokenization. Um, if you are taking on any project related to NLP, if we first do text pre-processing, like suppose we have a data set which contains a lot of data uh, in text format, we are doing text pre-processing. So in this text pre-processing, the first step is tokenization. So let's see what is tokenization. Tokenization simply means splitting a sentence into smaller parts called tokens. Like we are splitting the sentence, that is called tokenization. These tokens can also be words, punctuations, or even complete phrases. So, okay, yes, it helps to break this into meaningful pieces that a computer can understand. Okay, here I have implemented many types of tokenizers with a sample paragraph. Okay, you can take out of your own paragraph and run it by your own to see what's happening. It can help you with many projects. First, I have taken a sample.txt file. This file, I have attached this content in description box. If you want to need it or you want to execute it with your own collaborative file, take it from the description box. I will attach it in that. Okay. First, I have opened the file. This file contains the more than 8 sentences. To execute and implement these types of tokenizers, I have included many varieties of sentences. Like see, I have attached the smiley contents, hashtag contents, special character contents. I have included the exclamatory marks. So to analyze what the tokenizer is exactly doing, so I have attached these different types of sentences. Okay. To implement the NLTK, first, you have to install the NLTK package. Without installing, you can't even execute a single command. I have installed earlier, so if you want to install using the pip install command, you can install the pip NLTK package. Okay. So after installing, I have imported the NLTK package. From that package, I'm going to tokenize. So from NLTK to tokenize, first I have simply done sentence tokenization and word tokenization using sent underscore tokenize and word underscore tokenize. These two simply just done the tokenization. Okay. Similarly, if you want to implement the sent underscore tokenize and word underscore tokenize, you can also download the NLT Punkt tab package from NLTK. So install NLTK.download Punkt underscore tab. Okay. Next, sent underscore tokenize is nothing but it can tokenize the sentences into, if you have a paragraph, it can tokenize the single sentences and append it into a list. See, the sentence 1 in a paragraph is appended as a element 1 in the list. Sentence 2 is appended as a element 2 in the list. Similarly, the word tokenize also. Every singular particular word is tokenizes and it is appended in the form of a single list. See, the first word doctor dot is appended as the element 1 in the list. Similarly, the words are appended. See, the full stop is also appended as an element in the list if you're implementing word underscore tokenize. See the particular minor differences also. It is varying depending upon the tokenizers. If you want to understand the complete understanding of tokenization, like how every tokenizer works, see the output differences carefully. Okay. Next, I have implemented the TreeBankWordTokenizer. What this tokenizer done is, see what the TreeBankWordTokenizer done. It's done. It tokenizes the sentences. In the word itself, it can contain TreeBankWordTokenizer. If you want to split it into the words, you can use the TreeBankWordTokenizer. It can preserve the contractions and numbers. It is useful in POS tagging, parsing, and machine translation. What it preserves means? Preserves means it can preserve contractions and numbers. What is contractions and numbers? See, here the contractions are preserved. In the previous one, the sentence, it's very interesting. The its is split into it apostrophe s. But here, check the TreeBank word tokenizer. It preserves the contractions. The word is split as its. In newer type of project, if you want the word is to be its, you can type this type of tokenizer. No, if I want to remove the apostrophe, then you can use the word underscore tokenize. Okay. Similarly, here the its is preserved. Let's it's preserved now. So here this type of tokenizer works like this. It can explain parsing, machine translations. Okay, done. The next tokenizer is WordPunctTokenizer. Here also WordPunct. In the name itself it contains word, so it automatically splits the word. How it is split? It strictly split the words and symbols. Okay, it doesn't preserve anything. Here see, text cleaning and the symbol analysis. Best using nothing, splits all symbols. It simply splits all symbols. Okay. Okay, see the tokenization rule. It splits the words. Backslash W is nothing but the words, one or more words. If you are, see, it uses if in that case if you want to use the words only, not want any apostrophe, special characters, spaces, then you can use the word punk tokenizer. Backslash cs is nothing but white space characters such as spaces, new line, tab. That is the backslash represents. See the output of WordPunctTokenizer. Doctor dot itself written dot. See, it's interesting how is it apostrophe yes. See, it splits all symbols and the words. Didn't even preserves anything. Okay. Here also I am interesting. I is splitted once, apostrophe is splitted once, and M is splitted once. Okay. See the output carefully. You can see, okay. Next, PunktSentenceTokenizer. In the word itself, it has contains sentence. So, in that paragraph, it splits the into sentences. See, sentence boundary reduction uses splitting the large text into sentences, but it preserves the abbreviations like daughter, dot, Mr. dot. So, if you want your text like I want Dr. Dot in your case, then you can use the PunktSentenceTokenizer, best used in document processing, machine translation, and summarization. Okay, see the output of PunktSentenceTokenizer. See, see in the paragraph, it is split into sentence, but the abbreviations are preserved with a with a element, with a single element. Okay, with a one element. Sorry, with a one element. But see, the doctor dot is split as an element in the list, and the Smith is teaching NLP is split as another element in the list. So if you want doctor dot as a particular element, or I want separately the abbreviations, you can use the PunktSentenceTokenizer. So it has contained the sentences split as a sentence. Okay, sentence tokenizer. Okay, then regular expression tokenizer. So RegextTokenizer. The regular expression tokenizer, we can give any expressions as a token if one. So it is nothing but custom rule based tokenization. Custom rule, for any rule, for any such kind of rules, we can customize these splitting operations. With the previous one like TreeBankWordTokenizer, WordPunctTokenizer, it runs on the specific rules. It has already predefined rules, but here we can specify our rules. So this is the advantage of regular expression tokenizer. In the regular expression tokenizer, we can split split as sentences also. We can split as words also. It depends upon our expression giving. See, user-defined regular expression tokenization rule uses creating custom tokenization logic. So best used in research experiments and custom NLP. Okay, customization is important. Note the word. Note the word customization. See here I have give the expression as \w. So words. W is nothing but words. Words with apostrophe I given. Okay. Words apostrophe I have given. So it tokenizes with respect to words with apostrophe also. It tokenizes the words, but it also includes apostrophe. I have given specifically no. So the output must contain the apostrophe also. See the output. It's interesting. It the apostrophe, the S is splitted. So another one. Here I am interesting. I apostrophe also included. Then M is splitted as another element. So if we want to implement this kind of case in your project, you can use regular expression tokenizer. See another example, \s plus \s is nothing but white space characters like space, tab, new line. I already specified before, no? So it's splitted based on the white space or tab or a new line. See, Dr. Dot Smith space yes space teaching space NLP. So it detects the spaces and splits based on the \s. So you can understand from the output itself. See, with respect to space and new line, it splits the words. Okay. Next is TweetTokenizer. TweetTokenizer is useful for informal and social media tokenization. See, um, it preserves the emojis, hashtags, and mentions. In the social media comments, you can specify hashtag, at smiley. You can use lots of special characters and the different characters. So to preserve these kind of things, we are using TweetTokenizer. Okay, TweetTokenizer is useful for processing tweets and comments. Okay, best used in social NLP, social natural language processing, and sentiment analysis. Okay, see, um, from NLTK Tokenize, import TweetTokenizer. It preserves every characters. In before, see, in the tokenizers before, the regular expression also here. Wow. And the three exclamatories is merged as a single one. But here, see, the individual exclamatory is splitted. See, similarly, hash NLP at OpenAI, the smiley, everything is preserved in this TweetTokenizer. Okay, if you want don't such kind of smileys and emojis now, then we can also remove it in the next steps of pre-processing. Here we are discussing only tokenization process. Okay, in the next step, if you want to remove, we can also remove it. I can take an example sentence for the explanation of tweet tokenizer. See the output. I had a great work, great week. Thanks to you. If you need, please reach out. It has Heartin World Smile Day. See this. Every singular Heartin is added as an element in the list. Similarly, the hashtag World Smile Day is also included in as a separate element in the list. See the space. This three heart space is also added as an element in the list. See this element is also an element. Okay. You can understand it completely if you are execute with your own context of sentences. If you want to make it as a good one, try it by yourself. So the next tokenizer is MWETokenizer. MWE is nothing but multi-word expression tokenizer. It is useful in merging phrases as a single tokens. So like if you want to um, add the words as a group, then we can use it like a multi-word tokenizer. See the example, you can understand completely. Say I have taken a sentence, good performance by Indian Army on Republic Day. The Indian comma army doesn't make any sense if I want, but the Indian underscore army makes sense. So I'm adding the words as an one particular unit. Here MWE tokenizer, Republic command day, Indian comma army. Dot add MWE Indian comma army. See, it has added the Indian underscore army. Like the two different words is merged as a single one. Similarly, the Republic comma day is merged as a single one. Republic underscore day. If you want this kind of case in your project, execute multi-word expression tokenizer. Okay, this is the end of tokenization types. In the next video, I will implement stemming, lemmatization, stop word removal, and the next kind of process.